Alright, so example 2, still graphing using a table of values. Notice on the previous example, 2 is positive, here 2 is negative, and we're going to talk about here in a minute why we want to compare these and see what this does to the quadratic. So, I picked the same x values again. Once again, starting out, I will provide the x values and then just ask you calculate what the y values are. So we're going to do the same thing. You're welcome to pause this video and start plugging in and see if we get the same answers. But I am going to move forward working these out. Always be careful with order of operations when plugging these values in. Okay, negative 2 squared is positive 4. Times negative 2 is negative 8. Negative 1 squared is positive 1 times negative 2 gives me negative 2. 0 squared, 0 times negative 2 is 0. 2 to the first, 1 to the second power times negative 2, and 2 squared times negative 2. Alright. So now let's go ahead and plot these, and once again we're going to plot these 3 center points. Be careful, some of us need to watch what axis we're working on when graphing. So, negative 1, negative 2 is going to be in the third quadrant, so negative 1 on the x, down 2 on the y to get that negative, 0, 0, and 1, negative 2. Once again, connecting it in a curve, not a sharp point. Okay. Alright, so that's still a quadratic. Also, if we go back to the first discussion on how to know if it's a quadratic, we can look at our second differences. If we were to look at our second differences here, we have to create a list of our first differences. So our first difference here would be negative 8 going up to 2 would be plus 6, negative 2 to 0, plus 2, 0 down to negative 2 would be negative 2, and this would be minus 6. So that's your first difference. If we look at our second, we'll verify that this is a quadratic because this is going down by 4, down by 4, down by 4. It won't always be 4 like it was in the example I did at the beginning. It's just a coincidence that these are very similar functions. Just verifying that every number in the second difference is the same. Alright, moving on. Example 3, I would like you to try this on your own. Make sure you write the function, and I will put this here. I'm going to give you the x values of the same negative 1, negative 2, negative 1, 0, 1, and 2. So I would like you guys to do this